Thank you. I'm Benedict, and here's my co-presenter Franz. And together we want to present today sktime and also how we integrate foundation models and deep learning in sktime. And afterwards we will also present an outlook about the sktime ecosystem. So, but first the question, who of you knows sktime? Quite a few. Very nice. For all the others, I will explain what sktime is. So, sktime is the only widely operable time series framework. What does this mean? In sktime, we are having a lots of different kinds of algorithms. For example, we are having forecasters, transformations, time series classifiers, distances, clustering, and a lot more. And for each kind of algorithms, we have several ones implemented, for example, ARIMA, but also Morai, which is one of the recent foundation models. And within each of these algorithms, there is a consistent API, so you can easily exchange in your code Morai or ARIMA. They're all having type information so that for each estimator, you know it's a forecaster, it can handle exogenous data, it can make probabilistic forecasts, and so on, and the same is valid then for the transformation. Then there are the tags a bit different. So wrapping up here, consistent API across all of the estimators. For each estimator, we know which kind it is, and we can have also some kind of mini packaging, so you can install just the forecaster, just the transformation, just deep learning based algorithms, and so on. So here's the short overview of how this then looks like in the end. The tag system, we are just showing a few tags. There are our algorithms, then the estimator type, transformers, forecaster, matrix, transform, pairwise panel, and so on. We are having authors, the maintainers, which shows who is currently responsible for the code, and then also dependencies. So for each estimator, we knew which dependencies are necessary to run these estimators. But sktime is more. sktime is also the only widely composable time series framework. What does this mean? So we are having here two kind of compositions. The first one is the detrender. The detrender, what it is doing, it's removing the trend from a time series. So it needs internally a forecaster. So you can compose various different detrender by just exchanging the forecaster. And for example, here's an exponential smoothing forecaster, and then the whole type of the detrending algorithm is a detrender. The second kind of composition I want to highlight here is the pipeline. So you can attach the detrender to a forecaster here, and then it will change the type of the pipeline to a forecaster. So, and this forecaster you can just use as all of the other forecasters. And then we are having also the desynchronized, and you can attach this again to the forecasting pipeline, and then it still remains a forecasting pipeline. So important here, there's a consistent API across the composition, and the compositors are itself first-class objects, so having a forecaster in your pipeline makes the pipeline to a forecasting pipeline. It's easy to plug in various algorithms, and you can even do hyperparameter search via grid search, for example. But sktime is even more. sktime is also an open source toolbox for time series ML. We are having unified interfaces, composable, modular architecture, as mentioned before. There's a permissive license, so you can use sktime in your closed license environments. We are having an open license policy, so if there is an interesting algorithm for you, then you can contribute it as well. It's well documented, and you provide the according credits. But it's also a community, so we are having mentoring programs, organized work streams, meet up every Friday with research talk, dev discussions, collaboration sessions. And finally, skTime is also openly governed, so there are elective roles as core developers, council members. The eligibility is merit-based, so if you are contributing to skTime, you will become eligible to stand for various roles, and the whole governance process is transparent. Okay, now let's dive into the main topic of the talk. The main topic of the talk is deep learning and foundation model. So I think Luca already motivated it a bit why we could use foundation model for time series. For all that joined this talk, I will recap it. So without foundation models, we are having one fitted model per time series batch. So at first we have an untrained model, then we train it on some time series, and then we can forecast. For the next time series, we have to do it again, again, and again. For foundation models, and it's a bit different. Now we can have one fitted model for all time series. So we are having one foundation model, and then we need to provide context to the time series, and then we can do forecast. And we do not need to train this foundation model, and we can apply this to various time series. So that sounds cool. Now the question is how to apply them. So without skTime, there are a few troubles here because it's often research-oriented code here. So if you're using foundation model for time series, you are often having some specific packages with pinned dependencies, and this can lead to conflicting dependencies in your source code in the end. We are having inconsistent and non-unified APIs. For example, if you take a look at the Morai forecaster and the tiny times mixer below, it looks very differently. And for example, for Morai, you have to initialize a Morai module, then pass this to the Morai forecaster, and then create a predictor out of it. And in contrast, the tiny times mixer, you create a module via loading the rates, and then you can just call this object to get your forecast. Furthermore, often no proper packages. It's not that professionally tested as in skTime, where we have a sophisticated testing framework, and as mentioned before, there are often research code, and that is often not really production ready. So there's a lot to do, and here's also an invitation. If you're interested in joining here and contributing here, you are very welcome, for example, for the API design of such foundation model, where we're currently working on. Okay, so regarding foundation model within skTime, these 6 models are almost implemented. 3 of them are in the newest release. These are Morai, Tiny Times Mixer, and TimesFM. For TimesFM, we are having the restriction that it's currently only working on Linux due to some dependencies of TimesFM. And other foundation models where we are currently having pull requests are like Llama, Kronos, and MomentFM. Now, how can you use these foundation models with skTime? Since they are forecasted, it's basically the same as for all of the other skTime forecasting algorithms. So first we do some imports, and then we are loading the dataset. It's looking a bit complicated because I load the Australian electricity demand dataset, and I just wanted to have one single time series out of these, and I also resampled these time series. And then we initialize the Morai forecast, and just by specifying here which weights we want to download, in this case the small model from Salesforce, and these weights are hosted on Hugging Face, and then internally then it will fetch these weights, if not already locally available. And then you can do the fit and predict. For the fit, to be API consistent, we are passing the contextual data that might also be used for refitting if desired by the user. And we are having some forecasting horizon, so in this case we are predicting the next 96 steps. And we can do the same also with the tiny times mixer, just exchanging this model, and then fit and predict is the same. And so here's the prediction. In green, that's the ground truth time series, and the first 2 days are used as are just the past values, and then we have 4 days of forecast. And yeah, looks pretty reasonable, except for this weird spike for Morai. Not sure why it's happening here. And yeah, so it looks very reasonable here. And as mentioned, the power of using foundation model with skTime is now we can compose them. Short recap, what does composing mean? In time series analysis, we are having multiple steps: differentiation, deseasonalization, feature extraction, and therefore we can use pipelines. Forecasting pipelines look like that, transformer, and then we multiply it with a forecaster and we're getting a forecasting pipeline. We can also wrap them to get, for example, better forecaster by using ensembles, or to get probabilistic forecasts by using backing forecasters or conformal intervals. And in this case, it would look like then probabilistic forecaster, and we pass the forecaster. And we can even combine them. So now let's check 2 examples for this. First, the pipeline. Here we're importing as an additional the differencer to the previous imports, and then we can create our pipeline by instantiating the differencer, multiplying it with the Morai forecaster. Then we can do fit again. We can then do predict again, and then we plot it together with the Morai forecast, with a plain Morai forecast. And in yellow now we see the pipeline forecast, and in the blue the original one. And yeah, in this case, this simple differentiation obviously worsens the model. So probably you need some hyperparameter tuning for this. And yeah. So continuing with the backing forecaster enables you to create probabilistic forecasts out of a point forecaster. And internally it bootstraps the time series, and then the bootstrap time series and all bootstrap time series are then forecasted, and out of this you can create a probabilistic forecast. So we create a backing forecaster using a bootstrapping algorithm and Morai forecaster, and then fit again, and we can predict and also can call predict interval. And here is the resulting prediction interval. To be honest, it's not the best prediction interval you can achieve. Probably with a conformal interval you get better calibrated intervals. However, it shows you it's working with skTime, and I think that's quite cool, because it enables you to use all of these skTime features together with foundation models. So, and now I would hand over to Franz, who will present how foundation models in skTime work under the hood and what's the future of skTime.
Right. Yeah, thank you very much. Benedict, quick question, how many minutes do I still have?
A bit more than 11 or...
Yeah, so about 10 minutes. Right, so talking a bit about the bleeding edge, what's currently in development, and also the greater outlook in terms of governance and design. So we're currently working, of course, with the general idea, skTime being a neutral marketplace for all these models, and we want to give our users as much as possible the opportunity to try out the models and maybe also compare them to more classical models. We don't take any stance on which model is the best, so you can try it out on your own if you want with the easy interface. And of course, if you look at foundation models, there is a number of challenges. This is, by the way, now the conceptual model of states and state transitions that we're internally using. And of course, this highlights that as compared to classical forecasters, there are quite some challenges because there are some common workflows here. For instance, so on the right-hand side in the green area is what the user typically sees. So you get an already tuned foundation model. The serialized model sits somewhere maybe on Hugging Face or in Kaggle or Replicate as a safe tensors or a checkpoint file. So you want to load that, but maybe also want to fine-tune that with a closed fine-tuning corpus inside your closed ecosystem. You may also want to manage the fine-tuned model. And of course, at the end, you have the context and output. So that's, of course, what you've seen before on the slide. But eventually, we also want to support, with a consistent interface, weight handling, fine-tuning. And if you think about what does open AI, open models mean, you also need to think about the initial tuning. So the possibility to train your own foundation model, or at least a domain-specific pre-trained model, without having to rely on the released ones. So this entire set of state transitions and workflows is what we want to eventually map onto consistent interfaces. And this is, of course, a challenge which is ongoing. You have seen that some of the foundation models are still have the status of pull request or being in progress. So there are, sktime is a permissive license open source project. We invite you to join, to contribute. So unlike the classical models on the top right, you see, for instance, on the top, we still have the unified interface, a Python class, but now you need to think about the weights, you need to think about the model codes, you need to think about the licenses, handling versions, and it has been quite a journey to see how much complexity this injects to building a unified interface here. So if you're located in Europe, you probably also know about the AI Act and handling multiple licenses here and code and versioning. Having consistent versioning is also not straightforward. So we have the API challenges, of course, global forecasting, pre-training using some time series and utilizing the model on others, handling the weights, so loading the weights from a hub or loading the weights from locally, storing them on a hub or storing them locally, handling the entire pre-training workflow or integration with the model hubs. And dependency management is also not easy because the model code may have dependencies, the weights may have even dependencies, and third-party, second-party packages will also have dependencies. We have experimental support for global forecasting now, so we would very much also appreciate feedback on how you think that is working. We have the basic designs for a model marketplace. There's already an estimator search. People can upload their models quite easily. So the design here is we are surprisingly, perhaps, or maybe not surprisingly, the only time series framework that is ecosystem integrating. So we are the only scikit-learn-like framework where you can access models across the ecosystem and combine them. We have this estimator search where you can search for tags. Our philosophy is there should be developer freedom, no gatekeeping. You can upload and index your models there. Users can choose whichever model they want, so now you can go and once it's done, you can try and compare all the foundation models. Do they really live up to the claims, or at the end maybe even fine-tune them on your own data? No other package currently allows this to the best of our knowledge. You have, of course, the foundation models in research repositories, but they usually are with non-interoperable APIs. We're intentionally open with tag system, dependency management, and we're constantly developing our marketplace framework. The ecosystem is growing. So recently we have onboarded PyTorch forecasting. That is currently one of the major deep learning packages for forecasting into the sktime ecosystem. And there's a growing ecosystem of second-party packages, meaning packages owned by third parties, but they're indexing on the marketplace. For instance, Profitverse has a re-implementation for and an extension for hierarchical data of the profit model. skchange offers anomaly and change point detection. So if you are developing a package, if you want it to remain openly governed, then talk to us or just make a pull request to the package. We're planning also to grow PyTorch forecasting into a vehicle for torch-based models, and that includes management of transformer-based models or foundation models if we're doing any vendoring. So in some cases, we're doing vendoring in order to relax the relatively strong dependencies in the foundation models. Maybe that's temporary or maybe that's permanent, we'll have to see. Also, in terms of community management, one thing I mentioned, we believe at skTime, open source AI should be recognized as essential economic infrastructure. So if you think about foundation models or building anything on top of that, probably many of you in the room are building end-to-end solutions using open source components, and we are following a bit of a different logic here. We have recently incorporated in Germany, but we're also looking to do this in other countries with a model that's different from the common model where you incorporate somewhere in the US and then the open source model or the package gets sold by gatekeeping. We think open source should be governed and supported by users, developers, and the society. So governed by the users of open source. We want to put you not just in power of your own data science, but also of the ecosystem. And if you want to talk to us, so in Germany, there's now the German Center for Open Source AI. It's a nonprofit in Baden-Württemberg with local government support. We're currently in phase 0. It's very new, so you can join as an open source project, a sponsored, affiliated, or incubating. We're looking for an inaugural set of open source fellows to build the open source ecosystem. You can shape the strategy of the institute, get recognition for your open source work with the goal to be openly governed and managed by the user in developer community. You can also collaborate with us so we can scope your open source needs or develop opportunities or even packages that remain under permissive license and open governance. If you're interested in that, work with us and follow the German Center for Open Source AI on LinkedIn for opportunity announcements. On the skTime side, we are an open community, so credits for foundation and transformer models. Recently onboarded core developers as well here. Sinu, Anirban, Benedict, Armagan, Pranav, Julian, Shlok, and Jindong. All of them either current core developers or mentees at skTime. 4 of them funded also by Google Summer of Code this year. The skTime mission statement that we also want to continue with the various organizations that we're founding: open source, permissive license, open and transparently governed, an academically and commercially neutral space giving you the tools that you need to try any model without lock-in, with a neutral standpoint, and mentoring and upskilling opportunities. So if any of this has been interesting to you, if you want to join skTime, contribute also to the bleeding edge area of deep learning transformer-based foundation models. There's tutorials currently hosted on Binder, video, introductions, just pip install, star us on GitHub, follow us on LinkedIn. If you're an algorithm developer, add your algorithm or contribute. Join us on Discord. If you're a user or developer, there's a contributor guide as well in the documentation. If you're a junior developer, you can join our free mentoring program. There's internships also announced every year at the usual times where internships are announced, or present at our meetup, present your use case needs, present your package. You're all welcome at skTime. Join us. Questions?
Great talk, thank you. I would like to ask you a question about multivariate time series. Multivariate time series, so great talk. I would like to ask you about that.
Yes. So maybe we also give one to Benedict, because I don't know. So is that the general question?
Yeah.
Can you check
Oh.
the box?
Okay, so multivariate, of course, time series are supported as a data type and by the tasks. Not all models, of course, support multivariate time series. So each model is tagged with whether it supports multivariate time series. It's a tag you can search on in, so at runtime with the Python utility all estimators or on the estimator overview. And if you have a model that doesn't support multivariate, there are a number of compositors which allow you to make the model support multivariate. And the standard behavior is broadcasting. For instance, in forecasting, let's say you have an ARIMA model which is not multivariate. You can apply it like any other model, and it will broadcast across variables, so it will just fit itself to every variable. And if you have hierarchical data, it will fit itself to every hierarchy, and that's also fully parallelizable with multiple backends that we support.
Thank you very much.
Yes, thank you. My question is, what would you use for automatically identify seasonalities, and can you remove the different seasonalities?
Okay, so we have, of course, everything, or maybe almost everything. There's a tutorial which you can look at for seasonality detection. So the basic pattern, I would recommend start with statistical seasonality recognition by ACF or PACF, and that has a type of a parameter estimator in skTime, and it spits out one or multiple seasonalities. And then you can plug this into a deseasonalizer or MSTL, right? We also have STL and MSTL, so that's like the classical statistical thing. Now, if you want to shoot with larger cannons at seasonality, you can do auto seasonality models. So a number of the models support auto seasonality recognition, also from second and third party packages like the Nixlevers or PMD ARIMA has auto models. And then you can do abstract tuning. That's like the biggest cannon, AutoML, and you target the seasonality parameter and other parameters. There's also a compositor, and we have various tuning schemas available like grid search, random search, and also Optuna integration and integration with scikit-optimize.
Could you just give a bit of context on, for the foundation models, what exactly is the input and output of those models? Like, are they just, and what are they trained on? Are they just trained on other time series data sets? Are they trained on other context? And maybe related to that, how are the outputs of these foundation models used actually in changing the estimates of the fitted models that skTime is learning? Like, are they biasing the optimization process in some way, regularization, synthetic data, or how are
okay,
the
so let me try to answer in sequence, because I think there are multiple questions.
Sorry. I'm just kind of
So
wondering
what are these models trained on? God knows, but of course you can see the claims of in the papers that's released on, so usually big public or sometimes non-public data sets. If you have been for the last talk, there's the references, or you can look at the references about the foundation models, and in these papers they usually, not always, provide claims on what these models are trained on. We haven't trained them. We are only constructing interfaces for our users to be easy, for it to be easy for our users to use. Now, what is the input and output? So most of these foundation models we try to map onto the existing forecasting API. So that's commonly fit on a context. So the context in the LLM sense, but fit is historical data, and then you forecast some time points ahead. So that's the base interface for zero shot. Then we have an experimental global forecasting or fine-tuning interface, depending on how we map it, where you can provide examples, but then predict on other time series. So that's the few shot or global forecasting mapping. And experimentally not released yet, some of these foundation models are multimodal, so you could also do anomaly detection with them sometimes, or time series classification and other learning tasks. In that case, we would be mapping it onto the unified APIs of different learning tasks. So The unified API defines input and output, fit, predict, pre-train, update. So anything that any scikit-time forecaster does is the input-output contract here. And we need to extend the contract, or we are thinking about how to extend the contract for things like serialization, weight handling, or fine-tuning.
So thank you very much. We are running out of time, so please thank the speakers again.